Problems with live steam injectors. This is part 1. The injector plumbing is very important, starting with the inlet from the water tank. Here's the injector on my traction engine. It's good to use this as an example because it's quite large. Over the years I've never really had too many problems with live steam injectors, and when there are problems they usually follow a similar pattern. The first thing that you normally have to do is open the water valve and let some water run out of the overflow. This cools down the injector body. And then as you open the steam valve, the water starts to come out of the overflow with a lot more force. The water pressure from the overflow of the injector increases and it looks like this. If everything on this traction engine was working fine, all I would now have to do is slightly close the water valve and the injector would pick up. And in this part of the clip it is actually working. As I back off the water to the injector, the overflow dries up briefly and it starts to pump the water into the boiler. However, this is not strictly correct. The overflow should be dry. But this one's a bit dribbly. And when I close the water valve a little bit more, this happens. The sound's a little bit odd because this sequence is running in slow motion, but you get the idea. It is now not injecting. Wherever there's water coming out of the overflow or steam coming out of the overflow, water is not being pumped into the boiler. And usually, once steam comes out of the overflow, you have to turn off the steam valve. Then you need to start the cycle again because the body of the injector is now very hot, so you open the water valve, which cools down the injector's body. This strange egg-shaped fitting near the injector is a check valve, which allows me to input the water outlet from my steam pump into the feed to the boiler. I'm now back in the workshop and this is an injector water valve and an elbow that I bought from Blackgates Engineering the other day. I thought it might be a good idea to start the plumbing again from the water end. In a previous video I showed what was going on inside this water valve, and I also showed that the internal diameter of the elbow was bigger than the one in the valve. In the foreground is the current elbow and valve, which I've just taken off the traction engine, and if you look carefully you will see that the water valve is a modified gas tap. On the bench at the moment is a 9/32 of an inch twist drill, and this is what the internal diameter of a piece of 3/8 pipe is. You can clearly see that the drill is an easy fit in there. When I measure the internal diameter of the union, it is 8 mm. But that is the internal diameter of the union, not the internal diameter of the pipe, which is about 7 mm. The first part of the job is looking promising. I would say that the hole in the first part of the fitting is 8 mm. Well, at least it is at the inlet end. When I poke the drill into the outlet end, there is a restriction. I'm going to need to drill this out to match the rest. This is a very simple job. I simply hold the part in the cross vise on the drilling machine and drill the hole 9/32 of an inch to match the internal diameter of the copper pipe. Here I'm drilling the valve. When this traction engine was in my workshop I did various jobs on it, and one of them was to open up the bore of this taper plug gas tap. I removed the retaining nut and banged it on the bench. This was just to break the taper. When I first discovered that the injector didn't work properly, I immediately blamed the water valve, which is usually the culprit. Any air leaks on the water valve will stop the injector from working. I used my belt and braces approach, machined grooves into the taper plug and fitted some silicone O-rings. This old gas fitting was originally designed to use an olive on a piece of copper pipe. So using a 5/16 of an inch diameter drill, I removed the restriction entirely. Then I blew all of the chippings away using my airline. What I'm doing here is applying some Loctite 542 to the outer end of the fitting as I refit the brass blanking plug in the end. Originally, when I reassembled the valve to the T-piece, I used some shim washers. This wasn't a good idea and they weren't really needed, so I'm removing them. I'm showing here that even when I tighten the tap housing in place, it's not even touching the shim washers and they're all still loose. It's worth remembering that this is not a pressure fitting, it's only going to be accepting water at atmospheric pressure. I unscrewed the tap body from the elbow, removed all of the pointless shim washers and fitted an O-ring. And this is just for fancy, it serves no purpose really, it tidies up the gap between the tap and the elbow. I'm applying some steam oil to lubricate the plug in the tap. Why am I using steam oil? Well, it's because steam oil doesn't generally attack silicone rubber like other oils do. Probably silicone grease would be better, and I do have some somewhere, but I don't know where to put it. This clip shows the tap reassembled with the quadrant and a stainless steel nut holding it all together. And now with the final application of some Loctite 542, I screw the converted gas tap into the elbow. I can now certify that this elbow and tap assembly does not leak. But what about this piece of pipe? I changed this pipe because the original piece was cracked. And when I soldered the fittings on the end, I didn't realise at the time that the gas tap used a taper arrangement. However, I don't think this leaks, to be honest. But I'm not happy with it. Mechanically, it's not good. So at this point of the proceedings, I thought, well, never mind, I'll make another union and silver solder it on the end of the pipe. I do not have a cutting tool that is angled at 60 degrees. So here I'm using a standard chamfer tool, but I'm moving it around to set the angle, using an existing coned union as a guide. With a piece of scrap brass bar fitted in the chuck, I test whether it's right or not. And this was a very good fit in the end of the tap. At this stage I'd measured the existing short copper pipe, including the fittings, at 2 1/8 of an inch, and here I've marked that measurement on a piece of phosphor bronze. At this stage I thought I was becoming a bit pedantic, and I really didn't want to make a special phosphor bronze fitting, because it wouldn't look good. Instead I tried an O-ring, but that didn't work because this O-ring was too big. When I tightened up the fitting, it chopped up the O-ring. Time to think again. I'm using a smaller O-ring that just sits down inside the taper, and this worked perfectly in conjunction with the little bit of machining on the flat part of the union by holding one end in the chuck and using a live centre to make sure the other end was accurate. I assembled the fitting and disassembled it, and it hadn't mangled up the O-ring and sealed perfectly. I'm quite happy with this modification now. Making the commercial parts fit in the same position would have been quite a difficult job. The elbow fitting and the tap fitting are now 100% airtight and watertight, all the way to the end of the short piece of pipe that connects to the injector. And that is it for this first part. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.